Section 9.1 is about inequalities, which is an interesting topic in the sense that back in Algebra 1, you definitely learned how to work with inequalities, and it probably seemed like an easy topic because for the most part, inequalities, you treat them like equations, unless you multiply or divide by a negative and then you have to change the direction. But pretty much what you learn to do with equations, you could do with inequalities. The bad news is that was a wrong impression. Unfortunately, inequalities are actually pretty profoundly different from equations, and as soon as we look at nonlinear inequalities, things are going to change dramatically. You won't be able to use your equation techniques hardly at all. And in order to get you prepared for that, we're going to spend a little bit of time looking at the overlap between inequalities and graphing, because this is probably the only way we're going to be able to make the more complicated situations intuitive. So we start with a fairly simple situation like this here, where the inequality we're talking about, yeah, it's got some fractions in it, but ultimately it's still a linear inequality, so that if you get sort of out of your depth, you can stop and do things the way you did back in Algebra 1. But we're going to use this to illustrate a new idea. And the idea is that if you talk about an inequality where one side has to be larger than the other side, each side of the inequality can be thought of as something to graph. So here, the left-hand side, f of x is 1/2 x plus 7 over 2. Just think of that side as a function and think about what its graph is going to look like. It's going to be a line. There's going to be a slope of 1/2. There's going to be a y-intercept of 3.5, and graphing that's going to be kind of ugly, but you can graph it. And you can do the same thing with this one here. And there's going to be a graph for g of x. It's also a line. The slope is -4/3. The y-intercept is 16 over 3, so graphing that's also a pain. But once you have these two things graphed, what this inequality translates as is where is f of x, the graph we're going to draw in red, where is the red graph bigger than, and bigger than in this case means above, larger than for a function would mean above, so where is the red graph above the green graph? So if you have a piece of graph paper, try graphing this yourself, and then see if you get the same graph I get. So you might want to pause and then press play once you're done. Alright, so the graph you end up getting here should look like this. The y-intercept for the red graph was at 3/7, and then it's got a slope of 1/2, so it looks about like that. The green graph looks like this. And the point of intersection is going to be important, and if you didn't figure that out when you were graphing it, you probably didn't know that was going to be important, but it is. And it's at 1,4. And if you're trying to figure out where is the red graph above the green graph, this is not a math challenge, this is a visual challenge. Where is it above? Well, it's above here. Look, the red graph is above the green graph over there. The only thing you have to do beyond that very simple look and see sort of technique is you have to realize that this inequality that we started with, it was an inequality about x, not about a graph. So if you're trying to figure out the answer to this inequality, for what values of x does this thing on the left end up bigger than that thing on the right, you have to look at that picture we've drawn and describe the answer in terms of the x values where that's happening. So the x values where that's happening are right along here. In other words, for the x's that are larger than 1. Now, I don't think this is easier than doing the problem the way you learned back in Algebra 1, but it is an alternate way of doing the problem, and this alternate way is really important, and here's why. I mentioned at the start, the way you do a linear inequality is very similar to the way you do a linear equation. Like in this case, you could multiply through and clear out the fractions and move the x's to the same side and move the numbers to the other side and so on, just like you would have back in Algebra 1. But if you're talking about a non-linear inequality, using equation techniques will actually give you wrong answers. It won't work at all. So, as an example, try this inequality here. And if you try it using equation techniques, I can probably imagine what you would do. You would probably factor, and then break it up into two, and then solve each individual one. And then you'd be kind of stuck, because you'd have two simple inequalities, and you wouldn't be sure how to combine them. And the two different ways that you might think of to combine them, turns out both ways are wrong. So unfortunately, if you're thinking to solve this inequality using an equation technique, like you learned in Algebra 1, it's doomed to failure. It's not going to work. So instead, what we're going to do here is we're going to solve this using this graphing technique. We're going to think of the left-hand side as a function. We're going to call this f of x, and that's a quadratic graph, so we're going to have to spend a little bit of time graphing the quadratic graph. And we're going to think of this side as g of x, and that one's really easy. I mean, g of x equals 0. That means a horizontal line at 0. So g of x is right along the x-axis there. It's kind of a boring graph, but it's easy to graph. Boring is easy. We kind of like that. So let's focus a little bit on f of x in some more detail. We are supposed to graph this thing. That is a parabola. And parabolas have two key things that you typically think of for graphing. One of them is the vertex, and that's actually not going to be too useful here. So if you graph this using the vertex and so on, you're kind of putting effort into something that doesn't have any value. Instead, what I suggest that you do is focus on the, what am I trying to say, x-intercepts. The x-intercepts are where this thing comes out equal to 0. So that is an equation, and we know how to solve equations. That was kind of the whole lesson I'm trying to teach you here is inequalities, you can't use your old techniques. But this is an equation. We can solve this perfectly fine using regular old factoring, breaking it up, and so on. All the regular solving for quadratics that you know and love. So x comes out to be 6 or negative 1. Those are the x-intercepts. So that means this thing will cross at negative 1, and it'll cross at 6. And it's an upward pointing parabola, not just any old parabola. So I'm going to draw a rough picture of this parabola looking about like that. Now, this is not a super accurate picture. This is a very sloppy picture. There's hardly any detail that's been done carefully here. I've done it in a very sort of haphazard kind of a way. But remember what we're trying to figure out here. We want to know where f of x is above g of x. Where is the red stuff above the green stuff? And you can see where the red stuff is above the green stuff. That's just visual. It's just look. Don't overthink it. It's above over here. And it's also above over here. Red is above green there. Red is above green there. Not in the middle. In the middle, the red stuff is below the green stuff. And then, just like we did in the previous problem, what you have to do is interpret this in terms of x's. So looking at this picture, identifying that the stuff on the left, the red is above green, and to the right, the red is above green. Turn that into the question of what are the x's there. And for this stuff, these are the x's below negative 1. And we've also got over here x's bigger than 6. Now, what about equals? Let me look at the original inequality. Oh, it was or equals. Well, that's very easy to fix. All you have to do is say less than or equal to negative 1, greater than or equal to 6. So if it's greater than or equal to, less than or equal to, there's hardly any difference at all. Just make the slight adjustment. Typically, the answer to something like this will be an interval notation. That's the expectation in most textbooks. So in interval notation, we have an interval that goes up to -1, so from negative infinity to -1. And then we also need to include the interval that goes from 6 to infinity on the right. So the interval notation of your answer would look like that. On a paper test, I would also accept this. Well, sometimes on a paper test, the directions will say this. It'll say interval notation. So make sure you read the directions. If it tells you interval notation, do it in interval notation, of course.